Hey class, it is Doug, and today we're going to go over a couple of things from chapter 2, and Dave is going to have the glory, my brother Dave, to teach these couple of problems since I did the last one, since we both teach college algebra. So I'll let Dave take it away. Good.
All right, hello class. So this is college algebra, and I've got two problems I want to go over, and brother Doug will be videotaping me doing these two problems. Okay, so here we go.
I think today is Siblings Day, isn't it, Dave?
Yes, it is. Yes, it is.
That's what you learn when you are on Facebook.
Okay, so here's the problem. We want to solve this inequality. So as you can see, it's an absolute value inequality, and it's a less than sign. Less than sign. So that means we got to remember which theorem to use. So here is the question. Solve 3 times the absolute value of 2x plus 3 is less than 21, and write your answer in interval form. So what do you think the first step is? Think about it. What am I going to do first? And here's what I'm going to do. Divide each side by 3. You want to divide by 3 to each side because you want the bars by themselves. So this is what we have. Now what am I going to do next? Think about it. I'm going to use the theorem. Let's remove the bars. With a less than sign, you just write one giant inequality. And there it is, without the bars. You have 7 on the right side and then the negative 7 on the left side. It's one giant inequality without the bars. Okay, the next step, what do you think? You got to subtract 3 to everything to get the x term by itself. So here we go. Subtract 3 from each side, and we get this. Negative 10 is less than 2x is less than 4. My goal is to solve for x. So what do we do next? Divide everything by 2 to get x by itself. So here's what happens. When I divide each side by 2, I get negative 5 is less than x is less than 2. Do not flip the inequality sign because I'm dividing by a positive 2. Since we want an interval form, there's our final answer. The interval from negative 5 to 2, use parentheses because there is no equal sign. There is no equal sign. It's just strictly less than 21. Okay, so that concludes that problem. And now let's go to the next problem. Okay, so here's the next problem. Let me get it focused here. So we're doing number 4 here. It says the height of a balloon in feet thrown in the air. Sorry, this is not coming. Okay, here we go. The height of a ball in feet thrown in the air with an initial velocity of 64 feet per second from an initial height of 5 feet is given as a function of time t in seconds. And then the function is s of t, which is like f of t, no big deal. S of t is equal to negative 16t squared plus 64t plus 5. Okay, so 95% of this problem is going to deal with just that quadratic function at the end. S of t equals negative 16t squared plus 64t plus 5. Okay, so notice it is a second degree quadratic function. That means the graph will be a parabola. The parabola is going to open downward because of that leading negative in front, negative 16t squared. Okay, so this is going to be a vertex problem, it looks like, because we have a parabola that opens downward. It looks like it's probably going to be a maximum problem because the vertex is at its height, its peak. It's the maximum value. Okay, so here is the first question. Question A, how many seconds until the ball will reach its maximum height? So see that word maximum? That implies a vertex problem. So the x-coordinate of the vertex is going to give us this answer. So think of the vertex as hk. So h is equal to the x-coordinate of the vertex, which is given by negative b over 2a. And that's going to equal a negative 64 over a negative 32. because as you can see over here, I identified A, B, and C. Okay, so when I plug in negative b over 2a, I get negative 64 over negative 32, which is equal to 2. So this means the ball reaches its maximum height in 2 seconds. Question B, what is the maximum height? So the maximum height is going to be the y-coordinate of the vertex, your k. So k is going to be plugging in 2 into our quadratic function. So the maximum height is going to be given by s of 2. We plug in the h of the vertex 2 into this function, and that will output k. So s of 2, so we're looking at this function here and plugging in 2 wherever we see time, t. So s of 2 is equal to negative 16 times 2 squared plus 64 times 2 plus 5, which is negative 16 times 4 plus 128 plus 5. And then when you simplify, you get 69 feet. So that is the maximum height, 69 feet. Done. Done.